Today, let us talk about Spring AI. In this tutorial, I will teach you how to make use of the Spring AI framework to integrate AI into your Spring applications. So we will start this tutorial with the introduction to the Spring AI framework itself. We will see what are its advantages and what are the functionalities it provides. And then we will create a simple Spring Boot application from scratch and then integrate the Llama AI. So for this tutorial, we will be using a fully local Llama LLM model. But that doesn't mean you cannot use anything else. So you can use the same code and the same examples that I am going to teach you for any AI model you have. And that is one of the main advantages of Spring AI. You can connect to any LLM model that is out there. So we will create that project and connect to an LLM model, and then we will see how we can give text inputs into the model to get the responses. And then we will see how we can give multimodal input. That means you can give text along with input. For example, we will be taking a horse image, we will be taking an online screenshot, and then give a text, describe this image, and give it to the model, and it will describe that what that image represents. And then we will finally see how to do streaming of result. So if you are familiar with the chat models like ChatGPT, you can see that when you ask a question, it streams the result. It doesn't wait for the whole response to complete. It will stream you the data one by one, line by line. So we will see that as well. So let us go with the first chapter, Introduction to the Spring AI. The best thing about Spring AI is that it is vendor agnostic. That means you can write your code once and have it connected to any LLM that is out there. For example, you can find LLMs from different companies like OpenAI, Microsoft, Amazon, Meta. All these have their own LLMs with its own pros and cons, right? The good thing about Spring AI is that it provides an abstraction layer on top of which we write the code. And this abstraction layer hides all the complexities and differences with these different LLMs and provides us with a standard API. So once we write our code using Spring AI, we can practically connect to any LLM that is small and big. You can connect to 1 billion parameter model to 405, 1 trillion parameter model without making any changes to your code itself. That is the biggest advantage of using Spring AI. And you know that the same companies have different models too. For example, with respect to OpenAI, you can find ChatGPT 4o, GPT 4o mini, and then there is like O1 preview. There is more coming in the future as well. So not only it is vendor agnostic, it is also like support all these different models from the same companies. So in this tutorial, we will be using the Llama 3.2 model from Meta. And in that case itself, we use two different models. First, we will use a simple 3 billion parameter Llama 3.2. And then we will go ahead and use the Llama 3.2 vision model, which is a 11 billion, a bigger model that can process both text and image. So we will see this in action today. And then there is also support for other components of the LLM. So you know that there are things called a RAG that I will show you in the next slides to increase the knowledge of the AI system. So these AI LLM models are pre-trained with the data up to a specific date. So after that, they don't know what happened, what is the recent data, etc. is not known. So you can give your own data through these kind of vector store systems and RAG, and the Spring AI is agnostic for that as well. So it works with a different RAG and vector store implementation available out there. So that is one of the biggest advantages of Spring AI. And the second one is seamless integration to Spring ecosystem. You know that Spring has been in the market for a very long time. There are many experts, many different applications, many different libraries. A lot of production systems are running the Spring applications. So the good thing about Spring AI is it integrates seamlessly into your existing Spring Boot applications or Spring applications. And then the implementation of Spring AI components uses the standard Spring components like beans and services and so on. So you can make use of the existing system and simply add a dependency and do some minimal configuration and make your application work with AI. So that is a very big advantage of the Spring AI. Then Even though the Spring AI provides this abstraction layer, it also provides you with auto configuration. This will become clear to you when we start our coding. So we will be using the Meta Llama model, and the only configuration we do to link to that LLM from our application is just one line of code, just one simple configuration in the application dot properties. That's it. The rest is auto configured. So that kind of simplification of AI integration is possible through Spring AI. And the third thing is multimodality. So initially, when the first LLM models were introduced, it was text only, right? Only text was there. But later, image input came, and then more kind of input, like you can give voice, you can give other things, even videos will be coming in the future. So Spring AI is up to date in that manner. So it supports text, which we will see in this tutorial. It supports text plus image. So you can give an image and give a text asking questions for that image. So you can give a code, and you can give a screenshot of a code, and then you can ask questions from that code itself. So you can give a picture of like something, like maybe a horse, and ask it to describe about that image. So the possibilities are endless, and the Spring AI is multimodal supported. And then there are many more things, but that is not in the scope of this tutorial. But I would like to just explain or just mention those major advantages of using Spring AI. And the first thing I would like to tell you is the function calling. So the function calling means you can write a function in your code, normal Java bean functions, and then link that to an LLM and ask the LLM to call that function. Let's say you want to make an application that track the system's health, like a server's health. You need an AI powered system monitoring application. Let us consider that. And then you want to sometimes give the data about the temperature and maybe CPU usage and RAM usage to the LLM. So how do you do that? So there is a way through this function calling by giving the LLM reference to a function. You tell the LLM that you call this specific function to get the data about the systems, about the temperature, and about the CPU usage and memory usage. So that is also possible. And the another common thing is called RAG. So I mentioned that a little bit before, and that means retrieval. RAG means retrieval augmented generation. So you know that in the GPT, the second letter P stands for pre-trained. That means when you are creating an LLM, you collect a big set of data and then feed that into the LLM model. So the LLM model will only know the data available in that data set you have trained it on. That is called pre-training. But if you want to use the application, or if you want to use the LLM for some things that are known to it, you can give it additional data through these RAG options. So there are multiple ways to do that. The RAG tools are available. So that is also supported by Spring AI. So there are many interesting things about it. So without further ado, let's get started. Let us start by creating a new Spring Boot project. I'll be using the Spring Initializer tool, start.spring.io, for creating the new project. And the settings, I will keep these as default, Java, Gradle, Groovy, and the Java version I will set to 21. And then as of creating this tutorial, the latest Spring Boot version is 3.4.0. So I'll use that. And regarding the group and artifact, I will add com.genuinecoder and then artifact Spring AI, and then the name learn Spring AI, something like that. And regarding the dependencies, first I need to add the Spring Boot Spring Web, because we need to start this application as a web application. And then the next library you add depends on the LLM model that you are going to use. For this tutorial, we'll be using the offline Llama model from the Meta. So I will be adding Ollama for this one. So remember, if you are going to use the ChatGPT from OpenAI, you can add that from here, like OpenAI. This OpenAI library is available. If you are using something else, something that is different from this, like a Bedrock, you can see, you can find those dependencies here in the dependency section. So the rest of the things are the same. The code is going to be the same, but here during adding the dependency, you have to choose which LLM model you want to support. So these two libraries are needed. So I will just generate this project and open this on my IntelliJ IDEA. I have extracted the project and opened it on my IDE. Now let us have a quick look at the build.gradle file. And here you can see that the libraries we added, Spring Boot Starter Web, as well as the Spring AI Ollama dependencies are there. So we are good to go. Now the next step is to configure the Ollama LLM in your system and then connect our Spring AI, Spring Boot application into the Ollama LLM model. So this configuration is very simple to do, and it is done through the application.properties file. So every configuration we do in Spring Boot usually is through the application.properties file, right? So with Spring AI also, it is the same. We connect our applications, or we configure our application to connect to the Ollama through the application.properties file itself. So the only thing you have to configure for the LLM is the AI model. So if you search for Ollama, you can find there is an entry called spring.ai.ollama chat model. So here we have to specify which model that is supported by Ollama is going to be used by our application. So this is interesting because the Spring AI not only support different vendors like OpenAI and Llama, it also support different models from those vendors. For example, if you are configuring the ChatGPT from OpenAI, you will be providing this key, spring.ai OpenAI API key, to connect to their server, because it is not going to be run on the local machine. And there also you can specify which model. So let me look for the model value here. So spring.ai OpenAI chat options model. And here we can specify like I want 4o mini or 4o, whatever OpenAI models are out there. So similarly for Ollama also, you can specify which model you want to run for your application. And if you look at the library of Ollama available in Ollama/library, you can find many different models. Different models from same companies with a different version. For example, the latest Llama version available is Llama 3.2 as of creating this tutorial. And if you search for Google here, you can find the Gemma model from Google. And there is also other companies' models like Mistral. So all of them can be easily executed by just providing its proper name and configuration here in the application or properties. Everything else remains the same. Okay. So here for this tutorial, I'll be using the Llama 3.2 model. And first thing you need to do is to download the Ollama. So Ollama is like a Windows application, or depends on your platform. So if you're running this on Linux or Mac, you can download Ollama for that. And then you have to download and install it first. Okay. Now, once you install it, you can access that from the command prompt itself. So let me open the CMD or your terminal, whatever it is in there in your OS, and just search for Ollama. Just execute the command Ollama, and if it is successfully installed, you should get the Ollama information like available commands and all. So if you want to run any model, it is as easy as providing the configuration like Ollama run, then specify the model you want to execute. So first, let me show you how I can run the Llama 3.2 3 billion input parameters. So this is the number of parameters, right? You might have heard of like 3 billion, 11 billion, 90 billion different models. So this is a reasonably good model, Llama 3.2 3 billion. So what I will do is I will run like Llama 3.2, then the parameter count like this. In my case, I have already executed this command before, so it is not downloading. So if you are executing it for the first time, then it will show you like a download progress. So it will download around 1 or 2 GB data, and then it will come into this section. So now it is ready to accept any inputs. So let me just give it a command. Hi, what is the origin of Java? So let me just ask a message like that, and here you can see Java was created by created in the mid 1990s by James Gosling. So that command is executed. Now, if you want to exit, simply type /by. Sorry, it should be by BYE, and then you can see it exited. So I have the Ollama installed on my machine right now, right? Now what I can do is I can specify whatever model I want to use for my Spring Boot application here in the chat model section. So here, let me give the value as Llama 3.2 directly. So Llama 3.2, and let us try with the 3 billion model. Okay. And that is the only configuration you have to do for connecting your application. If you are running the Ollama in some other servers or some other computers, then you can specify the URL, or if it is running on some specific port that you customized, then you can provide the URL here. But if you didn't make any custom configuration, then just providing this chat model is enough as a configuration. Now let us start our coding, and let's see how we can make a simple request to the LLM model. So for that, let me go into the main class, Learn Spring AI application, and it is just a simple Spring Boot starter. The first thing I would like to do is to configure a chat client for the LLM. So what I am going to do is to create a package configuration, and inside the configuration, I would like to add a Java class named the chat client configuration. And this is going to be a configuration. So I will add the @configuration annotation. And here I will be specifying a bean. Yes, the auto suggestion is correct. So I'll be creating a bean for the chat client. So the chat client comes from Spring framework, so Spring AI. So Spring AI chat client. And this is an abstraction that provides or that facilitates the integration with the different AI providers. So all our interaction will be happening through the chat client, so that we don't have to worry about what LLM it is connecting to. So this is the main abstraction layer that we are going to have. So I need to create a chat client here. So for that, what I need is I need to use a chat client builder, and through the builder, I will simply build. So if I want to do some extra customization later, I can always customize it from this builder by providing some extra specification like addresses and functions. But we are not going to do that at the moment. So we just configure a chat client just like that. Now let us create a package for controller so that we can create a chat API, right? So in the controller, let me create a Java class that is going to be a controller. So let me name it as message controller. Maybe chat controller is better. So let me name it as chat controller. And here it is going to be a REST controller so that I can make REST API requests, right? So that is fine. Now what I am going to do is I am going to create a get mapping. And for that, I will put public string chat. Okay. And for the chat, I need to first get the message input from the user, right? So here I will provide @request param string message, and here I will specify it as message. And here I will provide the endpoint as chat. So the users can make a request to the chat endpoint with the request parameter message. And now we have to pass this message into the chat client so that we can process the input through the LLM. And once it is processed, it will be returned as a return value of this function. Okay. So what we are going to do is we need to auto wire we need to do dependency injection of the chat client. So I'll do chat client. Let me make it as final so that I can do constructor injection. So it will do the constructor injection for the chat client. Now here is where the magic happens. Here what we will do is we will use the chat client and go with the prompt function. So that will prepare a request builder, and here we have to pass the input through the user function. So you can see there are multiple overloaded functions. So we have a string option, we have a resource option, we have a little bit more complex consumer option. So for now we will use the text option because we only have to send a text message into the LLM. But later in this tutorial, when we are sending complex images along with the text, we'll be using this consumer option. Okay. So for now, we will use the user option message, and then we will call the LLM using this call function, and then we will get the response, right? So that response can be processed and we will get the string back using the content option. So that is all you have to do. So we will just return this one. So return chat client prompt user call content. So let me explain this again. We have built a chat client using the configuration using the chat client builder. And then what we have done is we called the prompt, then passed the data, then made the call and returned the response from the LLM back through the API. So the controller endpoint, right? Now let us run our application. So before doing that, let me build the Gradle project. Okay, the Gradle project is ready. Let me start our application. While the application is starting, let me open my task manager and show you my system configuration. So I don't have that much of a high-end system. As you can see, the CPU is at least couple of generations old, and the graphics card is previous generation, and it is also an entry level GPU 3060 Ti with the 8 GB memory. So the reason why I am showing you this is you really don't have to use an online API or online hosted AI services to test these kind of AI applications. So yes, using the same code you can connect to any other AI service and run this code. But if you have a decent system, or at least not bad systems with a GPU, bare minimum GPU, then you can run this locally and test whatever you want. Okay. Now let me open Postman. So I have the Postman open here, and let us try our API, right? So we have the chat endpoint, and we accept a message, and once the Spring Boot gets that, it will be sent to the LLM. So let us try that next. So I have the message here added, and what message? Let us start by hi. What things can you do? So let us ask the AI what are the things it can do, right? So I'll be giving this message and make a send request, and let me show you my CPU resource usage, the whole system resource usage. As you can see, it's used the GPU to process it. Also, there was like a slight memory usage increase, and I got the result. It is saying that I can be used in variety of ways, from helping you plan a vacation to creating art. So we got our LLM respond to our very first chat message. Now we can ask more things like what things can you do? How can I make maybe biryani? So if you want some food preparation suggestions, cooking suggestions, or cooking steps, you can ask our LLM, and it is processing that request. And as you can see, it created the whole steps. So biryani is a popular South Asian dish, and whatever you need to do, the step-by-step instruction, etc. So our first test with the AI client with the message is now successful. With the text-only input is successful. Now let us see how we can process an image along with the text. So we will be showing an image and giving a question along with that image, and let's see how this can process the multimodal input. Let us now update our application to accept images along with the text inputs. So the first thing we need to do is to update our LLM model. So the current model we are using is the Llama 3.2 3 billion model, but that doesn't support multimodality, and it doesn't support the image input. So it only accepts text input and output text results. So here with the Llama 3.2 vision, it supports the image input, so we can use that one. So it is slightly bigger. So previously we were using a 3 billion model, right? And here it is going to be 11 billion. So we have to use that one. So the 9 billion, I cannot run it on my local system because it is too big for my GPU and RAM, but I can run the 11 billion model. So if you have an 8 GB GPU, then it is supported. So what we need to do is instead of Llama 3.2, I will give the Llama 3.2 vision, and I will specify that I will be using the 11 billion model. So that is the first thing we have to do. And then we will go into the chat controller and let us create a new endpoint. Okay. So for that, I need to submit an image, right? So it is not going to be a get mapping. I will be using a post mapping. So post mapping. And then instead of chat, I will give chat with the image as the endpoint, and here I need a message, so I can have the message. So here I will provide at a request part, so that it is a multi-part post request. So one part would be the message, and another part would be request part multi-part file. So we will be using this multi-part file for accepting the uploaded image. Okay, now what we need to do is here in the user section, like I told you before, we have to use the fourth overloaded function. So consumer prompt user spec. So I will add the option like this. So I'll specify a prompt there, and inside the prompt I have the option to give different things. So here you can see there's a text option and there is a media option. So using the text option, I'll be passing the message that I just received, and using the media option, I can pass the image I received through this request. So here in the media section, I need to provide what kind of image I am giving. So I'll be mostly providing the PNG. So let's say we want to provide PNG image, right? So I'll provide the PNG, and then here I need to provide a resource value. So here this is a multi-part file. So if I give that directly, it is not working. So what I can do is I can convert this multi-part file into a resource using input stream resource. So I'll be converting that into an input stream resource using just like this. And I can convert it into the lambda expression. So replace with the lambda, and let me just arrange the code in a way that it is easily readable. So I have the prompt, and as text I have passed the message, and as image I am passing the file I have received through the multi-part request. Now, since that is done, let us go ahead and restart the application, and we need to find an image, right? So let me go ahead and check for in the browser. So let me go into google.com and let me search for something like a horse running on a beach, something like that. Something I want to ask the AI to describe or something. So I have this image. Let me take a screenshot of that like this, and let me save that. So I have used the snipping tool. Let me save that into the desktop. So desktop, and here let me provide it as input.png. Okay, so far so good. Now let me open the Postman and let us make another request. So the next request is going to be a post request. So it is going to be localhost yes 8080/chat with image. And as the input, I have to give both the message and the file, right? So what I will do is I will go into the form data section, and here the message is going to be, let us say, describe this image. Okay, so we will give an image and ask the LLM model to describe what it sees. So describe this image. And regarding the image, I have to provide it as a file here. So can I provide it something like here? Yeah, request part. Let me change this to have a name, part a name, so I can specify the part as image. So here image, and to choose a file, what I can do is I can choose this drop down, and there is a file option, then select file will appear, and from the select file, let me choose that input.png file. Now that we have selected it, let us send the request, and it is currently processing that. So it is processing. Let me open my task manager. As you can see, it is processing on my CPU, GPU, the RAM, everything is being used. So if you are using an online API based LLM, then this would be like instantaneous. But since this is local, it is going to take a little bit of time based on the system resources you have available. So now it is complete. And here you can see it says that the image depicts a horse galloping on the beach at sunset. The horse is a white with a long mane, and it has black horse. It not only described that image perfectly, it also did with an artistic touch, right? Like if to be frank, if I am writing that describing that image, it won't be like this good. So that we have successfully verified. Now I would like to show you one more example, like what are the use cases of this one. So let's say you want to learn, you are a programmer and you want to do some real-time queries regarding the program that you are doing. And let's say you are learning the SQL queries. So let me search for SQL join queries. Yeah, SQL join queries. So there is an example here. Yeah, you can see that here, right? W3 schools. So there is an example SQL join query. So let me take a screenshot of this one and save this to desktop. So, and that is going to be, let me name it as just a code. So like code.png, right? Now here, instead of describing the image, let me ask it to explain. Could you please explain this, and I am not specifying that this is a code or anything. I am just asking a generic question. Could you please explain this? And let us see how it handles such kind of image and queries. Is it able to handle the context properly, even for a local model? So let us wait for the processing to complete. And while it is processing, I would like to discuss with you one limitation we currently have. If you're, I am sure that you are familiar with the LLMs like the chat GPT and Cloud Sonnet. And in all those cases, the response is a streaming response, right? It is not like you wait for a couple of seconds and then out of the blue, you get the whole result. It is not like that. It will start writing. Basically, it is streaming the response. So it will write first line, then the next line, then the next line, like that. So here in this case, I don't want to wait that much time to get a response, right? So for that also, Spring AI has an option for streaming the response. So I will show you that also in a moment. So here, as you can see, the SQL query is designed to join two tables, orders and customers, on the basis of the shared column customer ID. Let us see if it is correct. So this is our host, right? This was our host, and here you can see from orders, inner join customers on orders.customer id equal to customers.customer id. So it is based on the customer id parameter. Yes. So yes, that is correct. So as you can see, it successfully identified that it is an SQL code. It also identified how it works and provided a detailed example on each of those steps. So our code for the multimodal input also succeeded. Now our endpoint is very perfect for that. And I would like to also show you like how to stream the results. So currently what is happening here is in the content section, this only return the value when you are fully done with the function call. Okay. Now if you want to stream the result, let me show you how that can be done. So chat with image, maybe chat with stream. So basically, you can do this for any kind of request, multimodal or text only. But for simplicity, let me do that just for message. So let me copy this one. That is easy. So chat with stream response, right? And now what you need to change here is instead of doing a call function, you have an option called stream. Okay. And when you stream it, you will get a flux of string. So I have a tutorial on the YouTube regarding reactive programming, and the flux is actually a reactive entity. So it is a publisher, and basically what that means is it will publish you a stream of data one by one. Consider it as a list, but it is not exactly a list. It is a streaming list that provides data one by one in that manner. So here what you can do is content, and you can return it. So here, instead of passing a string, you can do flux string. And let us see what is the problem. So I have used the same function name, right? So chat with flux, okay? And that is what you have to do exactly. And the problem is I can't show you the response directly on Postman because Postman, as of creating this tutorial, doesn't support streaming text responses. So I really can't show you in Postman. But what I can do is here after the stream, do on each. Next. Yes, I have do on next option. So what I can do here is I will be sharing this flux back to the requester, whoever made that request. But while doing so, for each of those response entries, I can actually get a value here, and I can print this on my logger. So what I will do is I will just do system.out. And I don't want a print ln. I just want to print it with the token. So for every response I receive, I will just print that to the system out so that I can see that in the logger. So let me restart the application. And then let me go into Postman because I still have to make that request, right? Only then this will get invoked. So I will make a duplicate. So here, let me click on this one, duplicate tab. And here, instead of chat with image, I will give chat with stream, right? So chat with the stream response. And it is going to be a get request. That is correct. And the param, I need a param for message. So message. Let me ask it like, what is your opinion about the Harry Potter book. I want it to generate a longer response. That is why I'm giving that kind of a subjective question. Okay. And as you can see, it is now writing. The conversation hasn't just started, and I haven't received any text information about specific Harry Potter book. However, I would be happy to discuss the series with you. So I didn't specify which Harry Potter book, right? There are like 7 books. So the conversation has just the Harry Potter series. So this way, you don't have to wait for the whole request to complete. So as soon as you start receiving a token, you can process it using a flex. So this is really helpful if you are developing a chat client or some applications like that. So in this way, you don't have to make the user waiting for the whole response to complete, and this will give them a kind of like a faster, because if I am waiting for a response indefinitely and I don't know when it is going to complete, it will feel like, yeah, I am waiting for a long time. But if I am getting the response, this kind of like a streaming response, then it will feel like much more improved user experience. Right now that it completed, I should have got that response here as well. So as you can see, it completed and I got that response in the Postman as well. So that's it, guys. I hope this tutorial helped you to get a better understanding of integrating AI into your Spring applications. So Spring AI is indeed an interesting framework. It has a lot of options. So far, we have covered how to do text input, text plus image, which is multimodal input. We have seen how to stream results, but this is just the tip of the iceberg. There are much more interesting things in the Spring AI framework. For example, there is a thing called RAG. There is function calling, which is called a tool integration. There is like observability. So a lot of extra options are there rather than what we have seen in this tutorial. So if you guys are interested, please let me know in the comments. I will consider creating a dedicated tutorial, maybe with a sample project for them. So until then, I will see you on the next video. Have a nice day.